So now that we're moving on to operations with fractions, there are a couple of things that you should know. There are specific rules that apply to operations in the terms of like addition and subtraction. So there are certain rules for addition and subtraction, and there's a different rule for multiplication, and there's a different rule for division. So we're going to start off with the rules for addition and subtraction with fractions. And remember, they're the same. So when we're adding and subtracting fractions, we need to make sure that the denominator is the same. The denominator is the bottom number. Okay? So here, let's try a different color, just so it's easy to differentiate. Here, we have a 9 and a 16. These are different. Once we have the denominators the same, we can add them. So like, let's say we have 1/3 plus 1/3. Because the denominators are the same, we can add them. And when we add them, we keep the denominator the same, and we just add the numerators, or the number on top. 1 plus 1 is 2, okay? Here, in this example, they're not the same. So what do? Well, we multiply them by each other, okay? So this side, we're going to multiply by 16. And whatever we do to the bottom, we have to do to the top as well. And this side, we're going to multiply by 9. Okay? So let's do 16 times 9. I'm going to do the math over here so we can take a look at it to make it easy to see. 9 times 6 is 54. We're going to carry the 5. 9 times 1 is 9, plus 5 is 144. So that's going to be our denominator over here. Sixteen times 5, 5 times 6 is 30. We put the 0, we carry the 3. 5 times 1 is 5, plus 3 is 8. So we end up with 80 over 144. Plus, we know here 16 times 9 is 144. And now let's do 13 times 9, so we can get the numerator for this one. So 9 times 3 is 27. We carry the 2. 9 times 1 is 9, plus 2 is 11. So we have 117. Now remember, when we're adding them, the denominator stays the same, right? 144, 144, 144. And what we're doing is we're adding the number on the top, the numerator. So we're going to do 117 plus 80, and that gives me, 7 plus 0 is 7, 1 plus 8 is 9, 1 plus 0 is 1. 197 over 144. Now let's notice something. The numerator here is bigger than the denominator, okay? Which means this is actually an improper fraction, which we have to turn into a mixed number. We're going to review that a little bit later. We're not going to worry about that now. We're just going to leave it at 197 over 144. Okay? So let's go ahead and move on. Go ahead and give this one a try on your own. Remember, we're making the denominators the same by multiplying them by each other. I'm going to give you a second to try it out, and then I'll go over it with you. Okay, here we go. So like I told you, we want to make the denominators the same. So we're going to multiply by the same number on the top and the bottom. So 17 on this side, 13 on this side. Like I said, same number top and bottom. We're working with bigger numbers, but that's okay. That gets us to practice with more complicated things. So let's figure out what our denominator is going to be. So 17 times 13. 3 times 7 is 21. So we're going to put a 1 and carry the 2. 3 times 1 is 3, plus 2 is 5. We're going to put that placement 0. 1 times 7 is 7. 1 times 1 is 1. So now let's add these together. 1, 5 plus 7 is 12. Carry the 1. 1 plus 1 is 2. 221. That is my denominator. Okay, perfect. Now let's do 17 times 8. So 8 times 7 is 56. So I'm going to put a 6 and carry the 5. 8 times 1 is 8, plus 5 is 13. So I have 136 up here, 221 on the bottom. We're going to do 221 here again. And now we're going to do 13 times 3 to get the numerator on the second fraction. 3 times 3 is 9. 3 times 1 is 3. So 13 times 3 is 39. So now we're going to add these together. Remember, the numerator stays the same. We're going to do 136 plus 39 so we can figure out what the numerator is. 6 plus 9 is 15, so we carry a 1. 3 plus 3 is 6, plus 1 is 7. We end up with 175. All right. Now let's take a look at the same thing, but this time we're looking at subtraction. So we're going to make the denominators the same, and then we're going to subtract the numbers. I want you to give this one a try before I go over it with you. I know we haven't done subtraction before, but because it's the same rules, I want you to give it a try anyway. Okay? I'll give you a second, and then I'll go over it with you. Okay, perfect. Here we go. So, we're going to do this side times 9, this side times 7. And whatever we do to the bottom, we're also going to do to the top. So 9 times 7 is 63. Sorry about that. 9 times 3 is 27. 1 times 7 is 7. 9 times 7 is 63. So we have 27 minus 7, which gives us 20 over 63. Okay? All right, that's our answer. Can we simplify it? Doesn't look like it. I'm going to move on. We'll have a couple other ones we can simplify that we can practice that together with. Go ahead and give this question a try before I show you how to do it. Go ahead. here we go. So I hope you got it. If not, don't worry. I'll go ahead and explain it to you now. If you have to hit pause, maybe rewind and look at it again and just kind of figure out at what step you went wrong. But here we go. I'll show you how to do this. So we're doing 8 on this side. Oh, sorry, no wonder. 8 on this side, top and bottom. 5 on this side, top and bottom. Because if we multiply them by each other, we get the same denominator. 8 times 2 is 16 over 8 times 5 is 40 minus 1 times 5 is 5 and 8 times 5 is 40. So now we're going to keep the denominator the same and we're going to subtract the numerator. The numerator is 16 minus 5, which gives us 11 over 40. 11 is a prime number, which means it cannot be divided by any number aside from 1 in itself. So we cannot simplify this any further. Therefore, our final answer is 11 over 40. Now that we've done that, let's go ahead and take a look at the multiplication rules. So multiplication rules are pretty simple. You're just going to multiply straight across. Let's zoom this in a little bit. So 2 times 3 is 6. 9 times 16, we do got to do on the side here. It's not as obvious. 9 times 6 is 54. We put the 4 and we carry the 5. 9 times 1 is 9, plus 5 is 14. So that's 6 over 144. Now this number can be simplified. We could divide both the top and the bottom by 2. So let's give that a try. 6 divided by 2 is 3, and 144 divided by 2. Once again, not so obvious, so let's go ahead and work it out. 2 goes into 14 7 times. 2 times 7 is 14. 14 minus 14 is 0. We're going to bring down that 4. 2 goes into 4 2 times. 4 minus 4 is 0. So 3 over 72. Now, can we simplify this further? As a matter of fact, we can. I'm going to show you a little trick. Here, we know 3 can be divided by 3. It can be divided by itself. And 72 can also be divided by 3. Well, how do I know that off the top of my head? It's not because I'm a math genius. I just know a little trick. If we look at a number, 72, for example, in this case here, we can tell if it can be divided by 3 by taking the numbers 7 and 2 and adding them to each other. And we get the sum. If the sum can be divided by 3, then the number 72 can be divided by 3. So let me give you another example of this. 144 equals 1 plus 4 plus 4. I'm looking at the sum of all the numbers in this digit. 1 plus 4 plus 4 is 9. Can 9 be divided by 3? Yes, it can, which means 144 can be divided by 3. Does that make sense? I hope so. So, with that said, let's do 72 divided by 3. Let's divide 3 top and bottom. 3 divided by 3 is 1. Let's put some equal signs here. And we're going to do 3 into 72 because that one's not as obvious either. 3 goes into 7 2 times. 3 times 2 is 6. Bring down the 2. 3 goes into 12 4 times. 12 minus 12 is 0. So that means that this is, oops, sorry about that. This is 24. This is the answer to this. Okay? Now, that took us a little bit longer because we had quite a bit of simplification to do here. And I also showed you a trick with 3s. So we can see how we can tell if a number can be divided by 3 or not. So don't get discouraged. Not all these questions are going to take you this long. Let's take a look at another one, okay? So next one, 7/12 times 3/14. I'm going to go over, actually I'm going to let you do this one on your own. Give this one a try. I'm going to do that for you. Give this one a try, and I will come back and show you how to do it. All right, good. Go ahead and good luck. Okay, so let me go over this one with you. Remember, we're not giving them the same denominators. We're just multiplying across. So we're going to do 7 times 3 over 12 times 14. Okay? 7 times 3 is 21. 12 times 14, we're going to work out here on the side because that one's a little more complicated. 4 times 2 is 8. 4 times 1 is 4. 1 times 2 is 2. 1 times 1 is 1. 8 plus 0 is 8. 4 plus 2 is 6. 1 plus 0 is 168. So it's 21 over 168. I got those numbers confused. Now, can we divide the top and the bottom by a number? Because we need to simplify this, right? 21 over 168. I'm going to put it down here so it's easier to see. Well, yes, we can divide by 3. 2 plus 1 is 3, which can be divided by 3. And 1 plus 6 is 7, plus 8 is 15, and 15 can be divided by 3. Remember the rule of 3 I taught you. So let's go ahead and divide both of these numbers by 3. 21 divided by 3 is 7, and 168 divided by 3, I'm going to do over here. I'm going to do it a little lower so we have space to work. So 3 goes into 16 5 times. 3 times 5 is 15, which gives me a remainder of 1. I bring down the 8. 3 goes into 18 6 times. So I end up with, 7 over 56. Now, can I simplify this further? Yes, I can. I can actually divide by 7 top and bottom. Because 7 can be divided by 7, and 56 can be divided by 7. So 7 divided by 7 is 1. 56 divided by 7 is 8. So my answer to number 6 is 1 over 8. All right, I hope you got that. I hope that was straightforward enough. We're going to move forward to division. If there was something you didn't understand in multiplying fractions, I encourage you to go back, rewind, and kind of see what you didn't get, okay? All right, let's look at division. So division is a little bit different. It has its own set of rules. Some people like to cross multiply with division. I don't recommend that you cross multiply with division because sometimes people cross multiply and they get confused. So I'm going to show you a way that you're going to always get it right and you're going to avoid confusion always, okay? So first things first, let's simplify this number, 9 over 12. I want us to work with small numbers. The small numbers help us to do less work in the long run. So let's divide by 3 top and bottom here and rewrite our question. 9 divided by 3 is 3. And 12 divided by 3 is 4. And this is divided by 6 over 7. Okay, now that we have something more simple to work with, let's look at the rules. When you are dividing with a fraction, what you do is you take the second fraction you flip it, and you multiply it. Now, what the heck does this mean? Don't worry, I'll show you. 3 over 4, and now because we're going to flip this second fraction, it becomes 7 over 6. This is called a reciprocal, okay? And we're going to turn that into a multiplication sign. So now, 3 times 7 is 21, and 4 times 6 is 24. And these can be simplified. We can divide by 3 on the top and the bottom. 21 divided by 3 is 7. And 24 divided by 3 is 8. So our answer to number 7 is 7 over 8. So just to recap, when we're multiplying with fractions, when we're dividing with fractions, we take the second fraction, we flip it, and we multiply them. Okay? So, I want you to give that a try. Let's see. Do we have another one? Yes, we do. With number 8. So give number 8 a try. It looks like these are perfectly simplified, so you don't have to worry about simplifying them. Just flip that second fraction and multiply. I will give you a chance to work this out on your own, and then I'll go over it with you. Good luck. I hope you got it. Here we go. I'm going to go over the question with you. So like I said, when we're dividing, I keep saying the wrong one. When we're dividing with fractions, we take the second one and we flip it. So we multiply by the reciprocal. So this becomes 3/8 times 2 over 1. 3 times 2 is 6. 8 times 1 is 8. We're going to divide by 2 on the top and the bottom because we want to simplify. These are both even numbers, so I know I can divide them by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. And our answer for number 8 is 3 over 4. Okay, I hope that made sense. We're going to move on to a new topic. We're going to move on to mixed numbers, which I promised you we would. Okay? But if you still had some questions or were unsure about how to divide with fractions, I encourage you to hit rewind or take a couple steps back and see how to do it. If not, you're more than welcome to email me and send me any question you like. Okay? So here we go. Mixed numbers. What is a mixed number? You've seen mixed numbers before. Mixed numbers are something like 1 and 1/2, 14 and 2/3, 6 and 1/3. Okay? A mixed number has a whole number and a fraction. A whole number and a fraction, a whole number and a fraction. They are together. Okay? Now mixed numbers come from improper fractions. So we have something like 5 over 4. This is 1 and 1/4. That's where it comes from. These two things equal each other. So how do we know it's a mixed number now. How do we switch between an improper fraction and a mixed number? Well, I'll show you. What we do is a simple division problem, okay? So we're going to go from improper fraction, let's do 7 over 4, to a mixed number. So we're going to ask ourselves, how many times does 4 go into 7? Well, 4 can go into 7 one time. We leave the denominator the same, and we're going to put our remainder up here in the numerator. How do we find a remainder? Well, 4 times 1 is 4. And 7 minus 4 is 3. So we have 1 3/4. Now, if that was a little difficult to understand, let me show it to you in a simpler way. This is like saying 4 goes into 7. 4 goes into 7 one time. 4 times 1 is 4. 7 minus 4 is 3. So remainder 3. Here, this goes into the denominator. This becomes our whole number. And our remainder becomes our numerator. Okay? Now, I hope that makes sense. I'm going to go ahead and do another example with you. Let's do 5 over 3. So 3 goes into 5 one time. My denominator stays the same. And what's my remainder? 3 times 1 is 3. 5 minus 3 is 2. So 1 2/3. Now, how do we switch back? Let's make some space here. I ran out of space. How do we switch back from a mixed number to an improper fraction? Well, it's pretty simple. Actually, it's easier than making a mixed number out of improper fraction. It's easier to go back. So let's say we have 2 2/3. What you're going to do is you're going to put a little multiplication and a little addition, okay? And you're going to say 3 times 2 is 6, plus 2 is 8. That becomes my numerator, and my denominator stays the same. So one more time, we'll do it with another one. 4 1/7. 4 times 7 is 28, plus 1 is 29, and my denominator stays the same. Okay? Now we can take a look at how to add mixed numbers. So mixed numbers have, like I told you before, a whole number, right? And a fraction with it. So it has a whole and a part of another part. And let me zoom in here. When we're going to add them, it's almost like we have to take an inventory and separate the whole numbers from the fractions themselves. So here we have 2 1/5. I like to line them up this way, just so it's easy. So I'm going to kind of draw, you know what, let me do it in another color for you. I'm going to draw a line here to separate the whole number from the fractions. Okay? So as we're adding, we're going to put the whole numbers on one side and the fractions on the other. So here we have 2 1/5. And here we're going to put 6/7. There is no whole number, there's only fraction. So I'm going to put it on this side. And I'm going to add it. Okay? So I'm going to always start over here on my far right hand side, because that's how I always add. Nothing new there. And it looks like we have to just add 2 fractions. Well, we know how to add fractions, right? It's just 1/5 plus 6/7. All right, so we're going to multiply each side by each other so we can give them the same denominator. And this becomes 7/35 plus 30/35. And that equals 37/35. Well, wait a second, this is an improper fraction. Well, let's rewrite it as an improper fraction. 35 goes into 37 one time. We have a remainder of 2, and our denominator stays the same. So now, we're going to add, we're going to carry, just like we do in regular addition, we're going to carry this whole number over to the whole number side. Okay? And we're going to put our results here, our sum, right in our sum part. Now 1 plus 2, we're going to add that in 1 that was carried over plus that 2 that was already there, and we're going to get 3. So this is 3 and 2/35. So, just to kind of recap, we set things up like this so that the fractions and the whole numbers are in separate sides. We add the fractions first. We always start with the fractions. We add them first. And then whatever we have left over, like let's say our fractions add up to become an improper fraction, that's totally okay. We make it a mixed number and we add the whole number over to our whole number side. Okay, let's give another one a try. As a matter of fact, why don't you give this one a try on your own? Remember to separate the fraction and the whole number, and I'll go over it with you in just a second. Okay, I hope you got it. If not, don't worry, we'll go over it now real quick. So I'm going to do 6 2/3. I'm going to separate them with my line again, just so you can see it. And so 6 2/3 and 1/4. Now I'm going to add them. I'm going to start with the fraction side, and I'm going to do 2/3 plus 1/4. I'm going to multiply by each other on each side. This becomes 8/12 plus 3/12, and that equals 11/12. Okay, so this is not an improper fraction. This is just a regular fraction, so I can just put it here completely normal. Awesome. And 6 plus 0, because there's nothing else to add to it, is just 6. So my answer to this one is 6 11/12. Okay, hope you got that. Let's keep going. Now we have a subtraction problem. Now we know with fractions, the rules are the same. The denominator always has to stay the same. So we're going to do this exact same thing with this one, okay? So I'm going to give you a chance to give this one a try. Set it up just the same way you set up the addition problem. Whole numbers on one side, fractions on the other side, and then subtract them. So I'm going to give you a chance to give it a try, and then I'll go over it in just a second. Okay, here we go. I hope you got it. I'm going to go ahead and work it out with you. So this time, I'm not going to draw the line for you. I'm just going to work it out and separate them regularly. So 9 2/8, 7 3/4, and we're subtracting these. Now we have 2/8 minus 3/4. Okay? Now here, what I can do is multiply this side by 2 to make it 8. I don't have to multiply them by each other. Okay? So 2/8 minus 6/8. Well, wait a second. 6 is too big. We're going to get a negative here. Okay, what do? Well, we can borrow from the whole number side. So when we borrow from the whole number side, this becomes an 8, and we're adding a 1 to the 2 8s. Sorry, not to this, to the 2 8s. So 1 plus 2 8s. Okay? Now, again, we have to give them the same denominator. This is 1 over 1 because any whole number is just over 1. And we're going to multiply by 8 to give them the same denominator. So this gives us 8 over 8 plus 2 over 8, which is equal to 10 over 8. So now that we have this new fraction, let's replace our 2 over 8 with 10 over 8. Okay? So 10 over 8 minus 6 over 8. 10 minus 6 is 4 over 8. Can we simplify this? Yes, we can. We can divide the top and the bottom by 4. And that actually gives us 1/2. So here we have 1/2 for the fraction side. Now, this, remember, became an 8. So we're going to do 8 minus 7 is 1. So this equals 1 and 1/2. So that was a tricky one, so don't feel bad if you didn't get it. We hadn't borrowed it before. Not a big deal. Go ahead and give the next one a try. All right, I hope you got it. Let me go ahead and go over it with you. So we have 7 3/5. Oops. Minus 4 3/10. All right, well, let's subtract these. 3/5 minus 3/10. We always start with the fraction. Here we can make this 5 into a 10, so if we actually multiply this side by 2, we'll get the same denominator. So there's no need to multiply them by each other. So this gives us 6 over 10, and we bring down that 3 over 10. 6 over 10 minus 3 over 10 is 6 minus 3, so 3 over 10. Now this one was great. We didn't have to borrow, okay? So 3 over 10 for our fraction side. And now 7 minus 4 is 3. So the answer to this one is 3 3/10. Okay. Now let's look at some multiplication. My recommendation for multiplication is to always make them in proper fractions before multiplying them. Now remember, we make mixed numbers into improper fractions by adding a little multiplication sign here and a little plus sign here. Multiplication sign here and a plus sign here. So 5 times 1 is 5, plus 3 is 8. And we're multiplying this. 10 times 2 is 20. 10 times 2 is 20, plus 3 is 23. Oops. And a little issue there. Over 10. Okay? So now we're going to multiply these two. Let's do 23 times 8, because that's a little tough. 8 times 3 is 4. Carry the 2. 16 plus 2 is 18. So we have 184 over 15. Now before we make this into a mixed number, can we simplify this number? Well, yes, they are actually both even numbers, so that means we can divide each of them by 2. So let's do 184. Let's work this one out. So 2 goes into 18 9 times. 2 times 9 is 18. 18 minus 18 is 0. Bring down the 4. 2 goes into 4 2 times. 4 minus 4 is 0. There we go. So this is 92. And 50 divided by 2, I'll work it out for you. 2 goes into 5 2 times. 2 times 2 is 4. 5 minus 4 is 1. We bring down that 0. 2 goes into 10 5 times. 10 minus 10 is 0. So 92 over 25. These are no longer both even numbers, so we can't divide them by 2. So let's go ahead and make these a mixed number, or make this a mixed number. So let's do 25 goes into 92, right? So 25 goes into 92 3 times. 25 times 3 is 75. Here we have to borrow because that 5 is way too big. 12 minus 5 is 7. 8 minus 7 is 1. So this is 3. We remember, the remainder in the numerator. 17 over 25. Okay? Awesome. Go ahead and give number 6 a try before we do number 7 with some division. I'll give you just 1 second, and then I'll go over it with you. Okay, so remember, first step, turn this into a improper fraction. So we're going to multiply it, and we're going to add it. 9 times 6 is 54, plus 4 is 58 over 9. And 7 times 1 is 7, plus 2 is 9 over 7. So I'm going to show you something. I'm going to show you a little trick here. This becomes 58 times 9 over 9 times 7. Well, when we have something that's the same in the top and bottom, like the 9, we can actually cross them out. Okay? When we do that, 9 divided by 9 is 1. 9 divided by 9 is 1. Sorry about that. 58 times 1 is 58. 1 times 7 is 7. That's how I got these numbers. Just in case I lost you there, I just want to make sure you're not confused. But when we do this, we actually save ourselves the steps of simplifying afterwards. So we're multiplying like this when we set things up in this stage. We can see if there's anything that can be eliminated, okay? I'm going to show you one more. So like, let's say it's 4 over 9 times 3 over 2. Here there's nothing necessarily the same on the top and the bottom, but the 4 and the 2 can both be divided by 2. So 2 divided by 2 is 1, and 4 divided by 2 is 2. And the 3 and the 9 can both be divided by 3. So 3 divided by 3 is 1. 9 divided by 3 is 3. Now I can multiply. 2 times 1 is 2. 3 times 1 is 3. And we get 2/3. Now, we could have just multiplied this regular. Let me show you again. 4 times 3 is 12. 9 times 2 is 18. And then we would have simplified by dividing on the top and the bottom by 6 we were to get 2 over 3. We would have gotten the same thing. However, we skipped a step, right? We saved ourselves a step by dividing by 6. I'm sorry, not here. By doing this over here, okay? So if that made sense, I encourage you to use that shortcut just because it's going to save you a lot of time. If not, don't worry. We'll just do it the traditional way, and I'll go over each step with you if that makes it easier for you. But let's come back over here. We have 58 over 7. So this is not quite finished. An improper fraction is actually not the simplest form of a fraction. So the way to make this completely finished is to turn it into a mixed number, which means we need to divide. So 7 goes into 58. Well, 7 goes into 58 8 times, because 7 times 8 is 56. And that leaves us with a remainder of 2. So my whole number is 8. My denominator stays the same, so it's 7, and my remainder, or my numerator, is now 2. Okay? So that's our answer. Okay. I hope that made sense. Now, when we are dividing fractions, or specifically mixed numbers, once again, we're going to turn them into improper fractions and then do the operation. Okay? So here, we're going to do 8 times 2 plus 7. So 8 times 2 is 16, plus 7 is 23, divided by 8 times 6 is 48, plus 5 is 53 over 8. Now remember, when we're dividing with fractions, we actually take the second fraction and we flip it, and we multiply the two fractions. Now here we notice there's the same top and bottom. So let's divide by 8. That gives us 1. That gives us 1. And 23 times 1 is 23. 1 times 53 is 53. Now can we simplify this? The answer is no. This is actually the simplest form. And that is our answer. Okay? Okay, I want to encourage you to give this one a try. I'll give you just a couple seconds to work it out. If you want to hit pause, you're more than welcome to. And then I'll work it out with you. Alright, I hope you got it. If not, don't worry, I'll work it out with you now. So, remember, we turn them into improper fractions, which means we multiply and we add. So 3 times 7 is 21, plus 1 is 22, and this is over 3. 12 times 2 is 24, plus 5 is 29, and that's 29 over 12. And we're dividing these, which means we're going to take the second one and we're going to flip it to multiply. So 22 over 3 times 12 over 29. Well, we don't have anything identical on the top and the bottom, but we have this 12 and this 3, which we can divide both of them by 3. So let's do it. Divide this one by 3, you get 1. You divide this one by 3 and you get 4. So 22 times 4 is 88 over 29. So, can we simplify this? Well, we can't simplify by dividing the top and the bottom by the same number, because 29 is a prime number, which means it can't be divided by any number other than 1 in itself. But we can simplify this by turning it into a mixed number. So let's do 29 into 88. Well, 29 goes into 88. I want to say twice. Let me work it out here for you. 29 times 2. Oh no, I can do 3 times. Sorry about that. Let's try 3. 3 times 9 is 7. Carry the 2 because it's 27. 3 times 2 is 6, plus 2 is 8. So it is 3. 29 times 3 is 87. 88 minus 87 is 1. So our answer is 3 and 1/29. Okay? I hope that made sense to you. I hope you got it. If not, hit rewind and review whatever it is you still don't understand. If you're ready, then let's move on. Congrats on finishing the fractions portion of this video. Today's lesson is really long, so this is a good one to take a break, take your time with it. If you need to step away, then go ahead and do so. When you're ready, come back and we're going to keep going and look at decimals. So, operations with decimals have different rules, and the rules change depending on whether you're doing adding and subtracting or multiplication and division. So the rules are the same for adding and subtracting, which means what you need to do is line up the decimal. So here, this 6 dot is just the number of the question, like the question number. So ignore that, but we're focusing on 2.9 plus 10.3. So what is that going to look like? Well, 2.9 and 10.3. Okay? That's what that's going to look like. Our decimals are lined up. If you can see that here, this is one decimal, this is another decimal here. Okay? And if you notice, my 10th place is lined up, my 1's place is lined up, and my 10's place is lined up. Okay? So now we add this, and we get 9 plus 3 is 12. So I'm going to put a 2, and I'm going to carry over the 1. Because there's a decimal here, I'm going to put a decimal in my answer. 1 plus 2 is 3, plus 0 is still 3. So I'm going to put a 3, and nothing to carry, so we just have 0 plus 1 is 13.2. Okay? So the answer to this is 13.2. So important to remember, line up those decimal points. I'm going to highlight it for you here. Line up those decimal points. These decimal points have to be together, and we keep them together here in your answer. Okay? So let's take a look at another question. I'm not going to bombard you with number 7. Let's look at number 8. Let's look at number 7 before you give one a try on your own. So here we have 5.72 plus 10.88. You see how we have the decimals lined up here? Now we can add stuff up. So 2 plus 8 is 10. 0, carry the 1. 1 plus 7 is 8. Plus 8 is 16. So we're going to do a 6, carry the 1. 1 plus 5 is 6. Please notice that I did bring down my decimal here. So I had my decimals and they're lined up. I'm going to highlight it real quick so you can see it. So these decimals are lined up here, okay? Where was I? Okay, so 1 plus 5 is 6. We didn't carry anything over, so we just have a 1 here. 0 plus 1 is 1. So the answer to this one is 16.60. But when there's a 0 and there's nothing behind it after a decimal, it also could be written as 16.6. They both mean the same thing. I just want to make sure to say that to you in case that's something that's confused you before, okay? All right, so give number 8 a try. I'm going to pause for a second, or you can pause the video, give number 8 a try, and I'll go over it with you just to make sure you understood. Now notice here for number 8, this is a subtraction problem. The rules are the same. You are still going to line up the decimals here, okay? Sorry about that. You are going to line up the decimals. Remember, the 8 is just the number of the question. But you are lining up these decimals, and go ahead and subtract them, okay? Good luck. Okay, perfect. I hope you got it. If not, don't worry. I'm going to go over it with you now. 6.6 minus 4.99. So this one might have been a little more challenging because we have this random space here with no number. Okay? So you have to make sure that the ones place is lined up and the tens place is lined up. But here, we don't have anything to be above this 9. So what we do is we fill it in with a 0, okay? Now remember over here, I'm going to bring you back to this real quick. Remember over here, we had 16.60 as our answer, but I told you that if there's a 0 behind the decimal, it doesn't affect you to write it 16.6. In the same way, if you have a 16.6, you can rewrite it as 16.60. So here we have 6.6. We can write it as 6.60. It's fine. It's not a bad thing. We can totally do that. Okay? So now that we've discussed that, we understand that, let's subtract. Well, we can't do 0 minus 9 because 0 is too small. So that means we need to borrow from the neighbor. Okay? When we borrow, this becomes a 5. We subtract 1 from here, becomes a 5. And this gets 10 added to it. 0 plus 10 is 10. So now, 10 minus 9, we can do it, is 1. 5 minus 9, can we do it? No, because 9 is bigger than 5. So we have to borrow from 6. This becomes a 5. Remember, we add 10 here, so it becomes 15. 15 minus 9 is 6. We just came across the decimal, so we're going to bring it down. And now 5 minus 4, we can do it because 4 is smaller than 5, and 5 minus 4 is 1. So our answer for number 8 is 1.61. Okay? I hope you got it. If not, don't panic. Give number 9 a try. And hopefully you'll get this one without my help. And if you can't, don't worry, I'll go over this one as well. Okay, so how'd it go? Hopefully you got it. If not, don't worry. Remember, the first thing we want to do is we want to line up our decimals. So 2.313 and 1.9944. And look at that. We got to fill in a 0, okay? So we can't do 0 minus 4 because the 4 is too big, which means we're going to borrow from our neighbor, and we're going to add 10 to this, so this becomes 10. 10 minus 4 is 6. 2 minus 4, we can't do it because the 4 is too big, so once again, we're going to borrow. This becomes 0. This becomes 12. 12 minus 4 is 8. Here, we can't do 0 minus 9, so once again, we have to borrow from our neighbor. This becomes a 2. We add 10 to the next one, so this becomes a 10. I'm sorry, that's a little difficult to see. Okay, that's a little better. 10 minus 9 is 1. So we've already used this one, we've already used this one, we've already used this one. I'm crossing them out so it's easy to see. Now we're 2 minus 9. That's what the one we're working on next. We can't do 2 minus 9 because 9, once again, is too big. So we're going to borrow from the neighbor. This makes this one 12. So 12 minus 9 is 3. We used it. We're going to include our decimal because it's lined up here. And 1 minus 1 is 0. So the answer to this one is 0.3186. Okay? So I hope that made sense. Give number 10 a try before we move on to multiplication. Okay, I hope you got it. Let's give it a try together just to make sure. Let me see here. Okay, so 16.301 minus, remember our decimals go lined up, so I'm going to put the decimal here, 4.0842. We fill in with a 0, and we get started. So here we can't do 0 minus 2. We're going to borrow. This becomes 0. This becomes a 10. 10 minus 2 is 8. Now here we can't do 0 minus 4, so we have to borrow from our neighbor. Now this one's kind of weird because we're looking at the neighbor, and the neighbor doesn't have anything we can borrow from. So before we can borrow from this neighbor, the neighbor has to borrow from their neighbor. So this becomes a 2. Oops, sorry. Let's zoom that in again. This becomes a 2. This one borrows and becomes a 10. So remember we were over here. We were on this one, okay? And we need to borrow from its neighbor because we can't do 0 minus 4. So now this one becomes a 9 and this one becomes a 10. Okay? 10 minus 4 is 6. 9 minus 8 is 1. 2 minus 0 is 2. Decimals are lined up, so we line it up down here. 6 minus 4 is 2. And 1 minus 0 is 1. So the answer to this one is 12.2168. That was a tricky one, so if you got it, congratulations. I'm really proud of you. If you didn't, don't worry. If you have to rewind real quick in the video, feel free to before we move on to multiplication. If you are ready, let's go ahead and take a look at some multiplication problems. Alright, so the rules with multiplication are a little bit different. When we multiply, we are essentially going to ignore the decimal points until we are finished multiplying. We only apply the decimal points to our actual product. And remember, product is the word we use for what we get when we multiply numbers together. So we're just going to write our number 6.8 times 4.7. I know here the decimals are lined up, but it's just because it happened that way. I didn't actually line up these decimal points. But we're going to do 6.8 times 4.7. So we're going to, remember, multiply, ignore the decimals, pretend they're not even there until the very end. So we're going to do 7 times 8, which is 56, we put a 6 here, and we carry a 5. Then we do 7 times 6, which is 42. We're going to add that 5 that we carried over, which makes it 47. And we're going to fill in with a 0. And now we're going to start with our 4, multiplying with our 4. So 4 times 8 is 32. I'm going to carry a 3. I'm going to cross out the 5 so I don't confuse myself or you. And now we have 4 times 6 is 24. Plus 3 is 27. So now that we've done that, we're going to add everything. Notice I haven't used my decimal points yet, okay? I'm kind of ignoring them for now. But there will be a moment where we will use them, so don't worry. So now 6 plus 0 is 6. 7 plus 2 is 9. 4 plus 7 is 11, so I'm going to put a 1, carry a 1. 1 plus 2 is 3. So 3196. Now that we've done that, we're going to go back and take a look at the decimals, okay? In my multiplication problem, I have one number behind the decimal point and two numbers behind the decimal point. So 1 and 2, which means in my answer, I will have two numbers behind the decimal point. So 1, sorry, that's going to be a little confusing. 1, 2. So my decimal point goes there. So the answer to this is 31.96. Because if my question has two numbers, 1, 2, okay, behind the decimal point, then my answer will also have 2 behind that decimal point. Okay? I hope that makes sense. Let's go ahead and do 12 together before I unleash you into the world of multiplication. Actually, go ahead and do number 12 on your own because I will go into the world of division soon. So do 12 on your own. Give it a try. I'll give you a second, and then I'll go over it with you briefly, okay? Hope that worked. It went well. I'll go over it with you real quick, just to make sure you got it. So 13.45 times 2.6. So here, please notice my decimal points are not lined up. I'm just going to multiply, okay? We're just multiplying here. So 6 times 5, we're going to start there, is 30. So I put a 0, carry the 3. 6 times 4 is 24. Plus 3 is 27. So I'm going to put a 7, carry the 2. 6 times 3 is 18, plus 2 is 20. So I'm going to put a 0, carry the 2. 6 times 1 is 6, plus 2 is 8. So I'm done with these. Let me cross them out so I don't confuse myself. I'm going to put that placement 0 here. And now I'm ready to multiply with my 2. So 2 times 5 is 10. 0, carry the 1. 2 times 4 is 8, plus 1 is 9. Nothing to carry. 2 times 3 is 6. Again, nothing to carry. And 2 times 1 is 2. So 0 plus 0 is 0. 7 plus 0 is 7. 0 plus 9 is 9. 8 plus 6 is 14. Put a 4, carry a 1. 1 plus 2 is 3. So now that I've done that, I'm going to go 1, 2, 3 numbers behind the decimal point. Remember, we're looking to see how many numbers are behind the decimal point. However many there are, 1, 2, 3, That's how many there are going to be in my answer. 1, 2, 3. So my decimal point goes there. So my answer is 34.970, and that's it. Awesome. I hope you got it. If you didn't, feel free once again to rewind and kind of see where you went wrong. And I'm going to go ahead and move on to division. Okay? I want to explain. So division has two different scenarios, okay? So sometimes in division we'll have, and I'm going to write it out for you so you can kind of see it. Sometimes in division we'll have the decimal here, okay, in the number that's being divided. Or other times we'll have the decimal out here. You see the difference? Sometimes we'll have the decimal in both places. Okay, so I'm going to go over all those scenarios. I'm going to start with the easiest one, which is this one. This is why this is the first question we're taking a look at. And then I'll show you how to do the other ones, okay? So let's take a look. Let's get started with this one. When we have a decimal in the inside, we just kind of line up the decimal. It doesn't really affect us too much. So I'm going to write this out so you can see it. 37, oops, sorry about that. Let me zoom in again for you. 3782.4. All right, so 22 goes into 37 one time, okay? Oh, 1. Okay, sorry about that. I don't know what happened. 37 minus 22. So just to make sure we understand, this number right here goes inside. This number right here goes on the outside. When we divide, we ask ourselves, how many times can this number on the outside go into this number here on the inside? And we go one by one. So like technically would have started as 22 goes into 30 times because 22 is way too big. But because it's way too big and I didn't want to write a 0 up here for you, I moved over and immediately started with 22 into 37, which I know 37 is big enough and 22 can go in once. So I put the 1 up here. I put how many times the 22 can go into 37 up here, and then I multiply them, 22 times 1, and I put the product down here, 22, okay? Now I subtract them to see what's left over. So 7 minus 2 is 5, and 3 minus 2 is 1. Okay, oops, I lost the 8 there. All right, there we go. Now that we've done this, to make sure we did this correctly, we ask ourselves, is this remainder smaller than this? It is smaller, so we can keep going. Now we bring down our 8. We bring down the next number to work with. So 22 goes into 158. Well, definitely more than once, okay? So one way I kind of like to do this when you're working with larger numbers is I try to round each number. So 22 is pretty close to 20, okay? And 158 is pretty close to 160, okay? So 20 to 160, I can multiply 20 times 8 to get 160. Okay, that could work. But I will say this. That might be a little too big. So to make sure I don't waste my time there, I'm going to do 22 times 7. Now, the reason we do this estimation process is to avoid writing like 4 or 5 different multiplication problems, trying to guess around to see which one works. You just want to go straight to it. And estimating helps you to find it as quickly as possible, okay? So here we go. 7 times 2 is 14. So we put a 4, we carry a 1. We're going to ignore this 20. That's not part of this. Just in case, I don't want to confuse you. 7 times 2, once again, is 14. Plus 1 is 15. Okay, so 22 times 7 is 154, and that's perfect. So I'm going to put a 7 up here because that's how many times 22 goes into 158. And I know that 22 times 7 is 154, so I'm going to put that down here. And now I'm going to subtract them to see what's left over. So 8 minus 4 is 4, 5 minus 5 is 0, 1 minus 1 is 0. I don't have to do anything with that. 4 is definitely smaller than 22. Let me clean this up for you real quick. And I'm good to go. So now I bring down, Now I bring down the 2. Okay. 22 goes into 42 one time. So I know, and I'm going to show you why. 22 times 2, 2 times 2 is 4, 2 times 2 is 4. It's 44. So I can't go up to 2. I have to stay at 1. Okay? So I'm going to put 1. 22 times 1 is 22. 2 minus 2 is 0. 4 minus 2 is 2. And there we go. Now we finally got, I know it took us a while, but we finally got to our decimal. Now, when we get to our decimal, we have to make sure that our decimal is lined up at the top where we're writing our answer is, and where it is inside that division sign, okay? So now that we did that, now we can bring down the 4 and we can keep going, okay? So now, 22 goes into 204. Guess what we're going to do? We're going to estimate, okay? So I know that 20, remember, is close to 22, can go into 200 about 10 times, okay? But I'm going to bring it down 1, so I'm going to do 9, just to make sure that we get it, because I think it'll be too big. So 22 times 9, 9 times 2 is 8. It's 18, but I'm going to put an 8 and carry the 1. 9 times 2 is again 18, plus 1 is 19. So we're going to do 198. Now, we can't do 4 minus 8. We have to do 14 minus 8. So we're going to have to borrow from the neighbor who's borrowing from the neighbor. This becomes 10. So we can borrow from it. It becomes a 9. And this becomes a 14. So 14 minus 8 is 6. 9 minus 9 is 0. 1 minus 1 is 0. Okay? Oh, I'm so sorry. I completely forgot to put a 9 up here for you. I'm so sorry about that. That could have been a big mistake. We could have gotten the question wrong. So I'm glad I realized it. But 22 times 9 is 198, so I put that up here. I bring down that 198 here because that's my product. And when I subtract, I get a remainder of 6. So now we can keep going, but this is going to give us a long decimal, and what I really just wanted to show you was what to do when you have a decimal in your division problem. So I don't want you to worry about getting rid of our remainders now. We're just going to kind of leave it here. Okay, we're going to leave it a little incomplete. Now, let's go ahead and, you know what, let's do another one like this. And I'm just going to write it for you by hand so we can get a little bit of practice, okay? Because the next one moves to a different kind of division with decimals. And I want to make sure you get this before we move on to that. So our next problem is going to be 3 into 26.4. Okay? So we're working with small numbers. We're just practicing using that decimal point, okay? So 3 goes into 2. We can't. It's too small. So we're going to move on to the next one. 3 goes into 26. Well, we know that 3 times 8 is 24, so we're going to put an 8 up here. 3 times 8 is 24. 26 minus 24. 6 minus 4 is 2. 2 2 minus 2 is 0. Now we get to our decimal point, which means we're going to put it up here, okay, behind the 8. Now that we've done that, we're going to bring down our 4. 3 goes into 24 once again, 8 times, okay? 3 times 8 is 24. 24 minus 24 is 0. Got it? So, let's do another one like that. I'm going to let you try this one on your own, and I'm going to give you a second to work it out. We're going to do 3 into 409. Let me extend that a little bit. 0.2. Yes, 409.2. Okay? Give that one a try. I'll give you a second, and then we'll go over it together just to make sure you got it, okay? Perfect. So now, let's do this one at a time. 3 goes into 4, 1 time. 3 times 1 is 3. 4 minus 3 is 1, which is smaller than 3, so we're good. We're going to bring down that 0. 3 goes into 10 3 times, because 3 times 3 is 9. So 3 times 3 is 9. 10 minus 9 is 1. Let's bring down that 9. And this becomes 19. 3 goes into 19 6 times, right? Because 3 times 6 is 18. So 19 minus 18 is 1. Now we got to our decimal. So we have to put our decimal before we move forward. Now we can bring down our 2. And this becomes 12. 3 goes into 12 4 times. 3 times 4 is 12. 12 minus 12 is 0. So our answer is 136.4. Okay, so now that we've gone over a couple of these, I hope you get it. I hope you see how we got to pause and line up that decimal. Now we're going to add another layer to this. We're going to look at questions that have the decimal on the outside, okay? You see how it has it here? Write the question, it'll make a little more sense. So let's write the question out. 1.4 into 624. Okay? Whenever we have a decimal here on the outside, we need to get rid of it. We can't keep it there. Okay? So what we do is we're going to move it to the right one time to get rid of it. It's almost like to hide it away. Now let me explain something. All numbers have a secret hidden decimal in them. All whole numbers do, okay? Even if you can't see it. So 5 is the same thing as 5.0, okay? Here, 624 is the same as 624.0, okay? So now with that said, if we're going to bring this over 1, we know that there's a decimal point at the end of this. Okay? 0.0. So if we do this, whatever we do to the outside, we're going to do to the inside as well. Okay? Which means this can be rewritten as, now it's 14, because we got rid of that decimal point. It's here at the end now. And that it goes into 6240, because we moved that decimal point to be behind the 0. Okay? I hope that makes sense. Now let's go ahead and divide. 14 goes into 62. I want to say, Let's try it out. I know 14 times 5 is 70. So let's try 14 times 4. 4 times 4 is 16. So we're going to carry a 1. 4 times 1 is 4 plus 1 is 5. So 56. We can't add 14 to this because if we do, we get to 70. So we're going to use 4 here, okay? So 14 times 4 is 56. 12 minus 6, sorry. I can't do 2 minus 6 because 6 is too big. So I have to borrow. This becomes 5. This becomes 12. 12 minus 6 is 6. And 5 minus 5 is 0. So I'm going to bring down my 4. Now, 14 goes into 64. I know it's going to go 4 times because I know 14 times 5 is 70. And I'll work it out here for you. 5 times 4 is 20. So I'm going to put a 0 and carry the 2. 5 times 1 is 5 plus 2 is 7. So it's 70, okay? So that's too much. So we're going to keep a 4. We're going to keep it at 4. So 14 times 4 is 56. We're going to subtract 56 from this. This becomes a 5 because we can't subtract 6 from 4. It's way too big. And this becomes a 14. 14 minus 6 is 8. Now we're going to bring down our 0. 14 goes into 80 5 times. And we know that happens to be 70. 14 times 5 happens to be 70. And now we're going to subtract and we're left with a remainder of 10. Okay? I'm not going to go over decimals right now with division. I'm just showing you how to divide with decimals in here. Okay? All right, let's take a look at another problem. Once again, I'm going to give you a problem. I'm going to write it for you. And this one is going to have the decimal on the outside and the inside. So let's say we have 1.2 goes into 3.684. Okay? Now, remember, we can't have this on the outside. This doesn't work. So I have to move it 1 to the back to get rid of it. So it kind of disappears, becomes invisible. And whatever I do to the inside, I'm also going to do to the outside. I'm sorry, I got that backwards. Whatever I do to the outside, I'm going to do to the inside. So this gets rewritten as 12 goes into 36.84. Okay? So now 12 can't go into 3 because it's way too small. So we're going to do 12 into 36. So 12 times 3 is 36. 36 minus 36 is 0. We got a decimal here, which means we have to line it up. Now I can bring down my 8. 12 goes into 8 0 times because it's way too small. But now we have to write that there because it's in the middle of our problem, like our answer. So we do have to write that 0, okay? So now that we've done that, 12 times 0 is 0. 8 minus 0 is 8. Let's do that. We're bringing down our 4. 12 times 7 is 84. We bring that down here. 84 minus 84 is 0. So our answer is 3.07. All right. Now that we got that, let's move on to another question. Give this one a try on your own before I help you out with it. I hope you got it. If not, don't worry, I'm going to go over it with you right now. So, let's write this. Oh, no wonder. Okay, 2.9 goes into 227. Well, guess what? I can't have this decimal here. I'm going to move it to the back, which means I have to move this to the back. Okay, so this gets rewritten as 29 goes into 227. So 2,270. So 29 cannot go into 22, but it can go into 227. Now 29 is very close to 30. And 227 is very close to 230. So if we count by 30s, if we multiply, we could do 30 times 7, which gives me about 210. That's pretty close. So let's try 29 times 7. So it's probably going to be like 29 times 7 or 29 times 8 or something like that, okay? So let's give it a try. 7 times 9 is 63. I'm going to put a 3, carry the 6. 7 times 2 is 14, plus 6 is 20. So we got 203. Let's try 29 times 8 and see how that works. 8 times 9 is 72. So we got a 2, we're going to carry the 7. 8 times 2 is 16, plus 7 is 23. 232. So even though 8 is pretty close, giving us 232, it goes over it, so we can't use it. We have to do 29 times 7. So we're going to put a 7 up here. 29 times 7 is 203. We're going to subtract these lovely numbers. 7 minus 3 is 4. And 2 minus 0 is 2. Okay, now we're going to bring down our 0. 29 goes into 240. We know it's going to be about 8 times, right? Because of what we did over here. So let's put an 8. We have to borrow because that is way too small. 10 minus 2 is 8. 3 minus 3 is 0. 2 minus 2 is 0. So we have 78 remainder 8 as our answer here. Okay? All right, awesome. You got through the decimals portion of today's lesson. We still have a little bit more. We still got to go over positive and negative numbers. If you're wondering when we're going to get to that part where we start talking about the word problems and the algebra and the geometry, we'll get started with that straight away tomorrow. But yesterday and today is just learning to clean up those little bits of our math. So when we get to the harder stuff, we're doing everything right, okay? So hang in there. Once again, if you need to take a break, feel free to do so. And when you're ready, come back and let's finish up today's lesson with positive and negative numbers. Positive and negative numbers. So positive and negative numbers can be confusing sometimes for people, and I just want to go over it with you briefly to make sure you understand how to do it before we start hitting those heavy questions, okay? So the best way to look at positive and negative numbers is to see whether or not they have the same sign. Now, a number carries a sign in front of it. So I'm going to zoom in here so we can really pay attention to one problem at a time. Here, this 5 is carrying a negative in front of it. And here, this 6 is carrying a positive in front of it. So we can look -5, +6. And the way we do this is with negatives and positives and adding them and all that, is if the signs are the same, we subtract. Okay? And the answer will have the same sign as the biggest number. Now, what in the world does that mean? Well, don't worry. I'm going to go over it with you right now. We're going to do number 1 together, and then I want you to give number 2 a try. Okay? So here, we're going to subtract them because there's a negative and a positive. Well, what's 6 minus 5? Well, 6 minus 5 is 1. Right? Now, it says that the answer will have the same sign as the biggest number. Which is the biggest number? The 6. So the 6 has a positive, which means our answer will have a positive. Now, we don't have to actually write positive one. You don't usually do that. But we're just going to, I just put it there so you could see it. But your answer is just going to be 1. So now that I did that for you, give number 2 a try and see how you feel about it. I'm going to give you a second, and then I'll go over it with you. Okay, I hope you got it. If not, don't worry. Here, let's look at the sign that has in front of it, -8 and +17. They're different signs. So, oh, I wrote here same. This should be different. The signs are different. Let's fix that there. I apologize. So if the signs are different, we subtract. The answer has the same sign as the biggest number. So here we have a negative and we have a positive, which means this rule applies. So we're going to subtract them. Well, what's 17 minus 8? 17 minus 8 is 9. We have a negative and a positive. Now, the answer will have the same sign as the biggest number. The biggest number is 17, which means our answer will be positive as well. Okay? Now, what if the signs are the same? So, this was wrong. We're talking about different signs here. But if the signs are the same, then we add them. And keep the same sign. Let's take a look. Let's move on. Here we have 12 minus 18. If there is no sign, that means it's positive. This one has a negative 18. The signs are different, which means we subtract. So 18 minus 12 is actually 6. And which is the biggest number? The 18, which has a negative, which means our answer will also be negative. All right, give number 4 a try. I'll give you a couple seconds. If you need to hit pause, and go ahead and do so. And then I'll show you how to do it. So with number 4, we have positive and negative. The signs are different, which means we're going to subtract them. 14 minus 3 is 11. 14 is the bigger number, and it has a negative in front of it, which means our answer will be negative as well. Now with number 5, we see here negative 6, negative 8. Or negative 6 minus 8. What's that rule? If the signs are the same, we add them. So 6 plus 8 is 14, and we keep the same sign, so it's negative 14. Okay? Give number 6 and 7 a try. I'll give you a couple seconds to do it, and then I'll go over them with you. Okay, so this is a negative 4 and a negative 13. They are the same sign, which means I add them. So I get 17, and the sign is negative, and I keep the sign, so this is a negative 17. Here we have a negative 2 and a negative 9. I add them because they have the same sign. 2 plus 9 is 11. The sign is negative, so I'm going to keep that sign, and the answer is negative 11. Now these look a little funky. Let me tell you how to do these. When we do these, we start applying the rules of multiplying and dividing positive and negative numbers, okay? Because we are imagining that there is an invisible 1 outside of this parentheses. So whenever we have a parentheses with like a positive in the outside or negative in the inside or outside or whatever it is, if we're trying to add and subtract positive and negative numbers and we have this here, we're going to pretend like there's a 1 in front of that parentheses, between the parentheses and whatever sign is in front of that parentheses. And we're going to multiply, okay? When we multiply, the rules are a little bit different. Positive times negative is negative. Negative times positive is also negative. So if the signs are different, the answer is negative. Positive times positive gives you positive, and negative times negative gives you positive. If the signs are different, we have negative. If the signs are the same, our answer will be positive, okay? So here, positive 1 times negative 4, positive times negative is negative, so this gives me negative 4. The negative 4 wins. The negative wins, I mean. Now we can go ahead and treat this like a regular problem and say, okay, negative 12 minus 4, these have the same sign, so I'm going to add them, and I'm going to keep the sign, and that gives me negative 16. Here, same thing. We're going to put that 1 in between the sign and the parentheses. We have negative 1 times negative 8. Negative times negative is positive, so this becomes 13 plus 8, and 13 plus 8 is 21. Okay? Congrats on making it through today's lesson. I know it's a long one, but way to hang in there and stay persistent. Like I told you guys earlier, we're going to keep going with these videos tomorrow. Day 3, we're already going to start jumping into those percents, those word problems, and things like that. So make sure you don't miss it. Below, you're going to find some practice for you, so make sure to check the comments. If you signed up for our text messages, then just check the text message and you'll find the link for the quiz in there also. Okay, good luck.